Okay, folks. So we have today's class to revise content, and I'm aware that you have. I'm aware that you have an assignment outstanding. I'm also aware I cannot tell you the answers to that. But if there are things which are causing you difficulty, I can talk in a general sense to that, or at least you can ask the questions and I can tell you, well, I can't tell you that answer, or I can elaborate in some fashion. What way do you want to run tonight's class? Do you want to have a revision section from the point of view of we'll do a couple of questions, and if there's elements or topics you're unsure of, I can kind of spend more focus on them and leave the questions about the assignment toward the end. Do you want to ask the questions about the assignment at the beginning? There's at least one question about the assignment. Someone's having an email. And so the short answer to the email you sent is I cannot tell you exactly how to do it. However, I can talk about what you might want to do. So the email that I got was basically talking about how do you keep track of longest word, longest sentence, short word, short sentence. So the way in my head I envisioned that being done is that you would have a loop, and again, as I said when I issued out the assignment, you can do this assignment in one pass through the loop, from start to finish. You do that once, you gather all the data you need, you can calculate everything at that point. You don't have to, but it is possible to do that. So what I would do is I would be keeping track of some information at every single character. So I'm going to have a loop that starts at the beginning, goes to the end, whatever string has been entered in. I'm going to evaluate that character that I currently am at. And I need to rule out a couple of options. So if it is a space, I need to understand what I'm going to do. Well, if it's a space, that's going to signify I found another word. So I need to do something to reflect that I found another word. If it is a full stop or exclamation point or question mark, then that would signify that I'm at the end of a sentence. And I would need to do something to reflect that, whatever that might be. At the bare minimum, we're keeping track of how many words and how many sentences inside that. So let's start at the easiest of those elements that were asked. You have to count how many words and how many sentences within that task. Now, we've done that assignment, or we've done that question in a couple of different ways. And basically what we're checking is, are you the category that says you're at the end of the word, or are you the category that says you're at the end of a sentence? And if you are, well, then I increment a different counter depending on which one it is. And that will inform me at the end, when I get to the very end, that, oh, I've come across that character 7 times. That means there are 7 words in this sentence. I've come across this character 2 times. That means there are 2 sentences. And the character you're looking for is going to be the one that's significant to ending a word or to ending a sentence. Does that make sense, or is that too cryptic? Spaces and full stops. Okay. But if it's not one of those, if it's not a space, if it's not a full stop, and in the assignment that I gave up, I realized after I kind of had put it together very quickly that I ignored or I factored in all of the other punctuation, so apostrophes and commas. I factored them as part of the word that they're at the end of. And so my calculations are ever so slightly off in the sense of, I think I said the average word length is 4.7, whereas if you remove all of the punctuation and only count alphabetic characters as the length of a word, well then you're looking to see it's about 4.39, I think is what it is, on the original paragraph that I put in off of the assignment brief. But if it's not a full stop and it's not a space, well, then what you're looking at seeing is, okay, well, it's a word character. It's a character within a word. So what do I need to do? Well, when it's a space, I say number of spaces gone up by 1. That means number of words gone up by 1. When it's a full stop, it means number of sentences gone up by 1 because I found another full stop. When it's a word character, so an alphabetic character or a punctuation character, like a comma or apostrophe, what I'm going to do is I'm going to say, in the current word that I'm in, I have one more character. So you're keeping track. Every character you go through, you're recording something. So you're either recording, I have one more word, I found a space. I have one more sentence, I found a full stop. And when you find a full stop, you generally have another word as well, because sentences end, I think, when the word ends. But if you have a character, like an A or a B or a C or a whatever it is, well, that's one more character in the current word that I'm in. If I hit the end of a word, I know how big the word I've just finished, I know how many characters that is, because I've been keeping track of how many characters there are. Which means I've got a comparison to make. Is this bigger than what I previously thought was the largest word? Is it smaller than what I previously thought was the smallest word? Remember, when you start this, when you're at the very first character of that string, you start processing through. To your knowledge, the largest word is 0 characters, because you haven't come across any word yet. And the smallest word, I wouldn't set it at 0, because then you'll never get a character larger than that. I'd set it at some ridiculously large word, like 1,000. There's no word in English language with 1,000 characters. Or you can set it to, I think, like int underscore max, which gives you the upper limit of what an integer can hold, 2.4 billion. But what it'll do is it means that any word you come across then, so the first word you come across is the. So, okay, so 3. Well, 3 is going to be, for the very first word, that will both simultaneously be the largest and the shortest word that you found, because you've only looked at one word. But if the next word is cat, well, cat's not going to work either, the horse, well then, there remains the smallest word you found, because you've counted the characters that go on. That's 1 character, that's 2 characters, that's 3 characters. That's a space, right? That's the end of the word. How many characters have I got there? 3. Okay. 3 bigger than this? Is it smaller than this? I've done all that evaluation. Let's move on. Another character. That was a space there. This is an alphabetic character. This is a new word. So this current word, count, horse. 5. Okay, so the last word is 5. My largest word I see so far is 3 for the word the. This is a bigger word. This is now my new largest word. My smallest word is 3. Well, 3 is smaller than 5. I can leave that alone. And I move on to the next word. And so what that will do is, as you go through the string, you're not keeping track of every single word. You're keeping track of the longest word, the shortest word, and the word you're currently in at the moment. So there's an element there of more than one action per character that you get. If I get to the end of a word, I probably want to reset that counter so that the next character I come across, the first letter of the next word, is going to be the first letter. I count as 1, and then 2, and then 3, and then 4, and then it resets for every word. But before I reset it, I can do that comparison. Is this bigger? Is this smaller? Work out where I'm going to go from that. As you process through the string, that will factor stuff through as we go through. It's going to, if you use the string that's in the assignment brief, it will give things like the word misdemeanor or misdemeanors has 13 characters, but it says it's 14. This is a comma right behind it. That's absolutely fine. I'm not going to Because my brief was inaccurate, I'm not taking marks off for that at all. If you don't do anything extra to remove out things like apostrophes and commas, I didn't, so I'm not going to punish from that respect. Same with quotation marks in the actual full text of wolf and lamb. Okay. That basic logic of I'm at a thing. Is it a space? No. Okay, I don't need to do those actions. Is it a full stop? No. Okay, I don't need to do those actions. Is it a character? Yes. Okay, well then I have a list of things I need to do. Next, this is a space. All right, I now need to do a couple of things. I need to increase my word counter. I need to check that last word. Is that bigger than the previous one I've come across or not? And get ready for the next word. That is a full stop. Now, what I've just talked about there a moment ago is how you would work out what the largest word is. But that can be extended to also count in the last sentence. So between the full stop, the full stop I'm at now and the last full stop that I was at, how many times have I come across this character? And there are different ways of doing this. I have seen full-time students who are basically, they will count, full stop, right. Do a substring from the start of the string to this full stop and take that sentence out. And then they check for the number of words, and then they check the largest word in that sentence, the smallest word in that sentence, and then they remove that word from the total string. And they have another counter to say how many sentences they've come across. And then they keep going until they get the next full stop, and they go from the start of the string, which is the start of the second sentence, to that full stop, remove it out, count how many words, what's the largest word, what's the smallest word, and keep doing that until they're left with an empty string. That's absolutely one way of doing it. You will have to get this. The easiest way to get this done is covering a topic we haven't covered. So that's not going to work. The way, in my eyes, that is the way I would approach this, based on what we've covered and only been allowed to use what we've covered so far, would be to have a lot of variables. I need to keep track of how many characters in the current word. What's my longest word so far? What's my shortest word so far? How many sentences have I come across? How many words have I come across? How many words have I come across in the current sentence? With those variables, whenever you come across a significant ending point, a space or a full stop, you will be able to work back to the last time you encountered that character, a space or a full stop, and calculate how many either characters in this word, words in this sentence, and then compare it against what you previously thought was the largest. Does that make sense? Stonewall. Okay. The other thing I'll say, and I kind of heard murmuring down here about that, is there is nothing wrong with having your counting variables, especially when those counting variables have to be used to factor in averages, to have them set as doubles. You can have a double variable number, and then go number plus plus, and it'll just increase it by one whole unit. But it allows it to basically go from 1.0 to 2.0 to 3.0, and that's absolutely fine. But when you come back to doing your calculation, a double will give you a number with a decimal point. If you have double answer is equal to characters divided by spaces or something to work out how many words are in the string, and characters and spaces are both integers, it will do that integer calculation, chopping off any of the decimal point stuff, and then as it moves it to a double variable to store it, it adds a 0.0 on the end of it. So you will get inaccurate calculations doing that. So I would advise, if you've got counting variables, count how many words there are, count how many sentences there are, count how many characters there are, store those as doubles. There's nothing wrong with storing them as doubles. It will just mean it's a slightly easier path to make sure you're getting your averages. Does anyone have any follow-up questions based on what I've just said? Has that helped or hindered your plan of how you're going to complete this?
It's possible to do it on the screen, like you think, just to try.
All right, but I get the grade for this assignment. Okay. how could I do this? So I obviously can't do something where I'm getting words.
No.
But let's say we've got I'm trying to think how to change the what I've talked about to make it relevant enough that it's still applicable without just giving you the answer, because I don't want to do that. Okay. So we've got a string here, and this string is going to be made up of lots of characters. And what we're going to do is we're going to put in brackets at random intervals. And what I'm doing is, let's say, for whatever reason, this is how we're going to calculate the number or the length of people's passwords. I've turned the word wrap on, that's why it looks a bit like that. If I were to zoom out more and more and more and more, you'll see it now fancy. This is one string, but if I zoom it in so you can read it, it'll wrap it round. No. Okay. I don't know how many there are there, but let's imagine. They're not spaces, right? Okay. Let's imagine that this is, so there was a large data breach from, who was it, that hotel group, was Marriott, yes, okay. Now, this isn't exactly how it happened, but every now and again, that's the most recent example of a massive data breach. Every now and again, you get these statements going on, oh, your LinkedIn account was possibly one of the 17,000 million accounts that have been hacked, and your password may be compromised, your credit card details may be compromised, whatever. Please go and change your password. And unfortunately, those type of emails where they're going, hey, someone got in, change your password, is happening more and more. So let's say I am on the security team there, and I want to say, all right, there's a vulnerability here somewhere. I need to find out what's the average length. If I'm trying to make my system more secure, I've got a bunch of users already, and I want to work out, well, what's the average length of their password? Let's say that's the only criteria I'm looking at here, is the number of characters in a particular person's password. And so you can see some of them here are pretty good, some of them are really long, some of them are tiny, and I want to figure out, well, what is it? What's the average password length? Okay, or what is the longest password we've come across? Actually, let's do that. Let's work out here's our bunch of passwords. I don't know how many they are. Also, this wouldn't be the way I would store them if I wasn't doing a program like this. The next topic we're talking about, arrays, will allow me to store this in a much more sensible way. But specifically, the assignment you're doing is meant to be done without arrays. So I'm going to, on this block of string here, I'm going to work out what is the average length of my password. So I can say, hey, there are 7 passwords of decent length, 2 very poor passwords, and 3 okay or acceptable passwords. And so if we're trying to increase our security, the poor and the okay need to be brought up to okay or excellent. I'm also going to keep track of what's the longest password I've come across. All right. So that's what I'm going to go with. That's my string there. I'm going to need some other stuff here. So this is my password string. Here I'm going to need to have my counter. Oop. Here. Again, I can't do all of this. So rather than keep a way of tracking what the actual largest password is, I'm just going to tell you the size of it. Okay? So because for your assignment, you have to be extra bit of actually tracking what that word would be in your case here. So we'll call it largest. set it equal to 0 for the moment. That's a pretty good one. Guaranteed if we set it to 0, every password we're going to come across is going to be larger than that. And int num passwords also set to 0 because we haven't checked any yet. So there's 0 passwords we've evaluated. So I have 3 characters so far. This one here is going to tell me. Actually. I'm also going to have another here called useful characters. Because this string here has a bunch of extra symbols, so the brackets aren't part of the password, so the password would just be that part. And the brackets are how I'm housing start and end of one password. So I'm just going to have useful character here to say if it's not a bracket, it's going to be part of the useful character. I'm going to divide that by the number of passwords to give me the average password length. Okay? Since I've just said that, then this should also be a double and not a double. And number of passwords should also be a double as well. They're the two that are going to be factored into my average, so I'll get to that in a moment. Okay, there are my variables here. So password, non-bracket characters. Okay, so I'm going to have a loop while my counter is less than s dot length. Okay, this is my loop. It's going to go true. It's going to do a bunch of stuff, and at the very end, we're going to go counter plus plus. Same type of loop as I'm going to use with nearly all my string examples. I'm going to say car C is equal to s dot car at counter. Get my current counter. Okay. So if I get my current counter now, I need to do a couple of things. The first thing I have to do is I need to evaluate what category does this character fit into. So if this character is going to be if C is equal to an opening bracket or C is equal to a closing bracket, then we're going to do one thing. Okay, so I need to do a bunch of stuff here. That's another the other type of characters we have there. We only have opening, closing brackets, and we have then our non-bracket character, basically alphabetic. So we'll just have an else here as our option. Okay, so if it's a bracket, if it's an opening bracket or if it's a closing bracket, I need to do a couple of things. So if it's an opening bracket, what do I want to do? Well, an opening bracket is going to signify the start of the current password that I'm looking at. So what I need to do probably, and actually, do you know what? Yeah, we'll separate these into different components here. I'm just thinking, as I'm thinking out loud in this again, this is a related but not an exact copy, so this will be a related but not exact solution or guide for how you should approach this stuff. So here we will have else if it's the other one. So we can check the two of them here. So we're going to check to see if it's an opening bracket, we do one set of things. If it's a closing bracket, we do another set of things. Otherwise, we're going to do something else. And we're going to do actions in each of these. So if it's an opening bracket, well, what do I need to do? Well, the first thing I need to do is I need to add in a new variable. The variable that I'm missing here is current password. I need a way of keeping track of the password. I'm in the middle. So if I'm here, I need to keep track of, well, how many characters so far have we got in the password? And I keep adding that up until I get to the end of that password. And then I can say, okay, that's how large that password was there. So I'm going to have here an int current password equals 0. If it's an opening bracket, Well, then I'm just going to make sure by saying current password is equal to 0. If it's the opening bracket, it signifies the start of a password. I need to reset that because the next character I'm going to come across is going to be a useful character. So I'm going to have to increase my counter as I move through that. And that's all I need to do if it's an opening bracket, I think. I'm coming up with this problem on the fly. I'm also coming up with a solution on the fly. So there may be a little bit of revision here. If you're typing it down, wait until I'm finished because there might be some stuff I have to go back and amend as I'm going through it. If it's a closing bracket, well, actually, let's skip the closing bracket. If it's not a closing bracket, it means that we're dealing with an alphabetic character. Sorry, if it's not a bracket character, either opening or closing, it's an alphabetic character. So I've got things I need to do here. Current password, plus plus. I found another character in the current password. Useful characters, plus plus. I found another. This is for my total average. Okay, so this one here is 2 current password. Here is for calculation. Okay. So that's that one there. So they're pretty much, I've done the 2 easier ones. If it's an opening bracket, I just reset this to 0. If it's not an opening or a closing bracket, I'm going to say, well, that's one more letter I found, or one more counter I found. I'm going to increase my current password, so that's gone up by 1, and my total useful characters goes up by 1 as well. If it's a closing bracket, well, here's a couple of things I need to do. If it's a closing bracket, then what I'm going to say is I need to evaluate that. So again, imagine how us going through this. We have that is not, oh, sorry. So we have this here. That's a bracket. We reset our current password back to 0. That's all we do. That's not a bracket. So we're going to say current character up by 1. So it becomes from 0 to 1. Useful character so far 1. Current character 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ending bracket. I know now I've hit the end of the password. I haven't done anything to alter this by resetting it yet. So I have this 11 at this example here to compare against my largest. So what I can say here is the first thing I'm going to do is I'm going to say if, what do we call it? Largest is smaller than current password. Then I'm going to, oh, I didn't put a semicolon there. That's wrong. Then I'm going to say largest is equal to current password. So if I come across a new maximum password, that becomes the new maximum. Does that make sense? So the next password, so the first one there is 11. The next one here is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is going to be larger than 11. So that's going to become the new maximum password. 1, 2, 3, not larger. We don't touch that bit at all. We've done our evaluation to make sure, but now that we've evaluated as false, leave it alone. We don't update our largest variable. Okay, so that's the largest password there. That's fine. The next thing I want to do is once that's done there, I want to num passwords plus plus. I found another password. I found the complete element of a password. Not the start of it, but I found the ending signifier, which means I've got the entirety of that password. And that's kind of all I need, I think, there. So let's have a look at the logic of this. Zoom that ever so slightly. I have a loop that's going to go from the first character to the last character. If my character is going to be a bracket, an opening bracket, I'm going to say reset my current password to 0 counter. And that's all I need to do. If it's a closing bracket, I'm going to check the current value of this current password. And if it's going to be bigger than my largest, or what I think is my largest password so far, it now becomes the new largest password. And since I found one more entire password, I'm going to go plus plus on that. So I've counted one more password on that. Otherwise, if it's not a bracket, if it's not an opening or a closing bracket, I'm going to say current password characters goes up by 1 because I found one more password-based character, and useful characters goes up by 1. I found one more useful character. And that's all our loop is going to do. And then it just moves on to the next character. So in every character we go through, we go, are you an opening bracket? No. Are you a closing bracket? No. Well, then you must be a password character. And I'm going to do the action there. Or it's going to be an opening bracket, or it's going to be a closing bracket. But I do something for every single character that I come across. And when the loop gets to the very end, I can create a new variable down here, which is going to be equal to useful characters divided by number of passwords. And that will store out that content from there. Okay? Does that make sense? So let's see if this runs, and then I'm going to throw it into Jelly so you can see it moving, so you can see what's happening. I think that's going to be a better way to explain this. So let's, I've saved that. So we're going to go here, we're going to go Java C, revision class Java. No errors, good. And then, oh, I have no output to this. So that'll run, but it won't tell me what's happening. So here we're going to say system dot out dot print ln. So it's going to be largest. Oh, I've missed an N, yes, thank you. And then we're going to print out average. Okay. Try that again. I'm going to try Java revision class. So that's going to tell me that 15 is the largest size password I've come across, and 10.1 blah, 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 blah is going to be the average length of that of the passwords. If I take all the passwords together and work at their average, that's what that is. And that kind of makes sense, because if you go back up to the top here and look at my string, and actually let's do it this way here. This is a kind of ridiculous way of doing it, but it'll add a little more. There. Okay, we're going to be. No, I won't do that because it's going to take too long to actually add all those bits in. Boy. Okay, but if you go up and have a look at the passwords here, that was 11, that was 15, that was 3, that's 6. This one here is probably about 8. That one there looks about 11. That one there looks. So if I were to, let's say, delete that one out, delete this one out here as well, and save that now. So I've got less passwords and probably, actually, you know what? That one looks large. Let's get rid of that one as well. Still tells me 15, but my average now, because I got less passwords in total, is 9.8. If I were to address this one here, so I'm assuming that's my 15 there. If I were to address this one here and add in some more characters, I should drastically change my, or quite significantly change my average by bringing it up by a half in total. So that's a similar-ish example to the kind of way I would expect you to look at this. Now you can see that I was able to calculate that one loop, and from that one loop I can tell you how many passwords. Oh, actually, sorry, that's what I left that out as well. I can tell you how many passwords I have on file. I can tell you the largest password, I can tell you the average size. If I had a shortest variable, I could be very quick to evaluate the shortest as well. So that's 4 of those pieces of information. I could, although I'm not going to do it for you, keep track of the actual password itself, or in your example, the word itself. So if you remember, I'm expecting for the largest and shortest word, not for the sentence, but for the word, for you to not only tell me how many characters, but also be able to tell me what those characters are. So print out that word for me. It's a slight addition onto what we have here. So it's just, the reason why I did this is it shows you that in one pass through where I do something for every single character, and I do different things for different characters because they mean different things in my program, that I can produce a reasonable amount of information. And with the addition of one variable, I could add in one more. With the addition of 3 more variables, I could add in 3 more things. So all I'm doing is I'm adding in more variables. My loop is still a loop. I have to do more expressions, make sure if I've checked for largest, I also need to check the smallest. But once I'm doing that, it's just another variable I need to store. Okay, well, that's a different one. Ah, that's a different one there as well. Ah, that's a different one there as well. So I'm able to kind of work through this. Let's throw all this code into Jelliet and see what it looks like. This one down here. There we go. That one. Let me get rid of that one there. Okay. Okay, that looks like it's going to compile. So let's run through this. We'll let it run. So it's going to create a string. It's going to add in a ridiculously large string into that. I'm going to create all my different variables here. So the string itself doesn't actually matter. What matters are these variables here. So we're setting up our counter, setting up the largest, setting up the number of passwords, the useful characters that we have within those brackets. And you can see it's converting it, or it's adding it to a double. I'm just going to speed it ever so slightly here. Okay, so it's going to go to the string. It's going to tell me the length of the string. So that string there has a length of, can't even see in this example here, 139 characters in total. So 0 is less than that, that's fine. Is this an opening bracket? So this will be slow because it has to go and do this action each time. But it's going to look at the opening bracket. Opening bracket, okay. Is opening bracket equal to opening bracket? Yes, it is. Well, what are we going to do? We're going to reset that value to 0, just in case it wasn't. Then we're going to increase our counter by 1. Move on. Get the current character, which should be whatever it is. Yeah, 1, that's fine. This is a really good example of the printing to the screen, whether it's like this or whether it's console printing, is incredibly expensive from a time point of view in your machine. If you got your machines to work without any printing, they would work, the software would work much, much faster. So you can see here that we got an S character, so we've increased our current password length by 1, and we've increased our useful characters wherever it is there, but it's 1 also. It's 1.0 because I've set it as a double. And so it's going to work its way through. So I'm going to speed this up again. But again, the important thing we're looking at here is we're checking to see, so now our current password is going up by 2, useful characters goes up by 3, and that's going to work its way through this loop. And unfortunately, we're going to be here for a little bit because but each time I go in here, I'm evaluating, is it a bracket? No. Okay, well then it's a useful character. So I'm changing the bottom 2 variables here. So these are going up by 1 each time. And when I get to the end of the particular string, which will be a while, so I'm going to stop this after the second password because I'm not waiting until it's all finished. So for 7 characters now in our current password. I think the first one has 11. But does this example give you a hint of what you should be doing? Hopefully. Turn current character is going to be D. Okay, so this is character 10. I think there's 11 in the current one. Yeah, so there's F last time. So the next character here is going to be D. Right. I need to slow it down again. Okay, we're up to the 11th character now. So let's check the 11th character. The 11th character is going to be. Right. Okay, so we have a closing bracket. So now we're going to go through this, and I'll step through this because this is the bit that's the interesting part. If I were to go on to the next one, it checks is my closing bracket. No, that's the wrong button. The same as an opening bracket. Well, it's not. No, we know that, so it's going to skip that part. Okay, so it moves on to the next one. Moves on to the if-else part. Is my closing bracket the same as the closing bracket? Yes, it is. Okay, so let's go in. Let's have a look. Our largest password here is currently at 0. But we're going to check to see, is that smaller than my current password length, which is currently at 11. So 0, less than 11. Yes, it is. Okay, so now what's going to happen is my largest password is going to become 11 because that's the first password I've come across. It's guaranteed to be the largest. It would also, if we had a shortest, it would also be the shortest at this point in time. If we find something else to contradict that. And we move on. Okay, super. Number of passwords goes up by 1 because I found one more password. Move on to next character. Next character is going to be, I'll explain from here without stepping through. Next character is going to be a opening bracket. It's off, gets the length, all that kind of stuff. Okay, so again, we have 11 here, we have 11 here. It's opening bracket, so we need to reset this one to 0. And this is only about 7 or 8 characters there. Unfortunately, that's not what we're looking at. We're looking at UWORD there, so that will take a little bit longer. But it's going to work its way through, and it's good the same counting. So I'm going to speed it up again while it counts through until we can see the evaluation, how we do the evaluation. A little bit faster. And obviously this is not a the best way of representing this, but it kind of shows you what's happening in the program, so that's why I leave it in. I would say there are about 9 characters in the next one. So I'm going to slow this down a bit because we're at the second last character here. Speed up a little bit. That's the first T. Increasing my useful characters again. Okay, so here we're getting the next character. This is the last character in the string or in that password, which is going to be a T. That's not an open bracket. That's not a closing bracket. So if we increase our characters by 1, increase the useful characters by 2. So if I pause it in a moment. Okay, so now we're at our closing bracket here. So when we add the closing bracket in, what's going to happen now is we're going to evaluate it. Is it an opening bracket? No, but it is a closing bracket. So we're going to go in here. And we can see that that's not true. However, if we look at the else if branch, that will be true. So we'll go inside. We're going to evaluate, is 9 bigger than 11, which it's not. So we haven't found a new larger password, but I have found a new number of passwords. So that goes up by 1. I move on to the next character, which is an opening bracket. And so the opening bracket is going to say, oh, well, it's an opening bracket. I need to reset this back to my 0 starting point. I can count a new password as I work through. And when it sets it 0, so it gets it's an opening bracket. Puts the opening bracket in char C at the bottom of our variables here. Checks it. It'll match the first one there. So yes, it is equal to an opening bracket. So I'm going to go in here and I'm going to say 0. And that will run on and run on and run on, but I'm not going to run that anymore. Okay, so you can see what's happening there as it's going through. It's evaluating every character. It's doing an action at every character. And I think that's the change from the previous examples I might have done with you guys and the assignment that you have now. Previous examples, it was if this is one of the subset of characters that I've defined. Is it a vowel? Is it a space? Is it a whatever? Well, then we'll do it. But for the majority of the characters, we're doing nothing. We're moving on to the next one. The difference here is that we need a condition for every single character. Now, you can see that inside this, if you think about the typable characters we have, which is about 106 characters in total on the keyboard, 2 of them are enumerated. And then all of the other ones, so let's say 104 of them, all fall into this category here of everything else. So while we have to have an action for every type of character, we don't need to enumerate you every single one. For you guys, for your assignment, there are particular characters that are important. Spaces are important. Full stops are important. And then you have everything else, which I won't say is not important, but could be the else part of your assignment as well. Once you've dealt with how do you deal with a space and how do you deal with full stop. Make sense? Okay. No.
Can you put that example in the drive?
Yep. I will. I'll do it now so I don't forget. Okay. Hopefully that answered. First of all, hopefully that was the question you were asking, and secondly, hopefully it helped answer it. I want that. Go away. See. Right, so that's up there now. Okay. So this is a revision class. Is there anything you would like revised? Yes.
Just have a general question and then kind of get on. Just find with the last assignment we had, the transition from doing the class exercises to doing questions that had multiple conditions. Just found it hard to.
Multiple conditions in your if statement or in your loop, you mean like that?
Yeah, so if you had any statement moving into a loop or a while or something.
Okay.
I just found it hard to separate the two.
Okay. Have you submitted the workbook at this point?
Yeah.
Has everybody submitted the workbook at this point? Okay. Well, let me put it this way. I'm going to go through the guessing game question to hopefully illustrate because that's a loop that has multiple conditions in there. So it is now 7:30 on the 5th of December. If you haven't submitted the workbook by now, I won't count the grade on your last question, just because if I'm going to go through a solution, it's a little unfair to everyone else in the class. Fair enough. But in that question, we had 3 criteria. So we had what happens if the user enters in the number correctly. You can can stop the loop then. What happens if the user enters in a negative number, they quit, or what happens if they enter in their 20th attempt, which means that they have lost. So you have a win, quit, and lose condition in that game. The way I had initially envisioned people doing it, and again, I'll reiterate that the examples that I do on the board are sample solutions. Especially in first year programming, if your solution works but doesn't look like mine, so for example, if you've just got one loop that counts from 1 to 20, and then inside that you've got two if statements, one to see if they've got it right and one to see if they've got it wrong, or if they've chosen to quit, then we can, and it works, it does what it's meant to do, but then that's still as valid as mine. As we move further into second year and third year and fourth year programming, there would be a bigger expectation on you following along with a particular technology. But for something like that question, where I didn't say you have to use this and you have to use this, I don't really mind how you do it. So what I'm going to do is I'm actually going to write it that way. I'm going to write it with one loop that this goes from 1 to 20. And when we hit 20, they're kicked out. That's it, you've lost. But inside that loop, we're going to check to see have they guessed correctly. If they guessed correctly, we'll still kick them out of the loop. We're going to tell them that they've won. And then we're going to check if they haven't won, have they entered a negative number? And if they've entered a negative number, they've chosen to quit. And then what I'm going to do is I'm going to alter that code to do all three of those in one statement at the top. Fair enough? Yeah. Cool. All right. Here. So file, save as. Right. So this question is going to require some stuff from me. So input, not input, import. It's going to require inputs. So we're going to have import java.util.asterisk. We're going to have here a scanner. This has got nothing to do with your question. I'm going to quickly could have thrown them together. Is equal to new. However, as I'm typing this, and I'm not really paying attention to or explaining much of this stuff because it's not relevant to the question that was asked, if you find that there's something there that you don't quite get your head around, shout out and stop me, and I'll talk about it then. Int, we'll call this guess, 0. Int num2 guess is also equal to 0 for the moment, and int attempts is also equal to 0. Okay, so I've got a couple of variables here. I've got my scanner, so I can take in user input. I've got my random for generating the random number. I've got the guess that the user is going to make an attempt at. I've got the number that I'm attempting to get. That's going to be my random number. And I've got the number of attempts that the user has made. So I need to keep track of have they guessed correctly, what was their input, so they might have chosen to quit, or how many attempts have they made. I'm going to generate my random number outside of the loop. That's very important. If you generated your random number inside the loop, you would have a brand new number to attempt to guess at every time you went around. So I'm going to have number to guess is equal to or dot next int. What did I say? Between 1 and 100? Was it? Okay, so it's going to be 100. That will give me from 0 to 99, and I'm going to have plus 1 to give me from 1 to 100. I'm shifting that window up by 1. I'm going to have a loop here that says while attempts is less than 20. Start at 0, finish when they get to 20, which means it'll go from 0 to 19, which is their 20 attempts that are there. Okay, we're going to ask the user each time. And then try and guess a number. Okay, so they're going to be asked to guess a number. They'll be asked to take in a number, or we'll give them the opportunity to take a number. So guess is equal to kv.next int. Okay. Now, at this point, I've taken their value in from them. So I need to do a couple of things to check. So the first thing I'm going to check is, have they chosen to quit? If they've chosen to quit, there's no point in me evaluating anything. If their number is less than 0, because the key was if they enter in a negative number, then it should be kick out. So if guess is less than 0, I'm going to print out system dot out dot print ln. Goodbye. And I'm going to break the loop. Okay. If that's the case, then they're gone. They've chosen to quit. That's fine. The next best option and the next least likely option is that they've guessed correctly. So what I'm doing here is I'm imagining that they've got 101 possibilities. They can enter a valid number between 1 and 100, or they can enter in a negative number, and I'll count all negative numbers as a single value. So they've got 101 possibilities. If they've guessed the correct number, that's one of those 101. If they've entered a negative number, that's another one of those 101. So I'm going to deal with them first, and the remaining 99 I'm going to deal with in my else block, because that's far more likely that when they make a guess, it'll be wrong rather than they've chosen to quit or they've won the game. So else if guess is equal to number to guess. And in this scenario here, I'm going to say winner. And I'm still going to break the loop. And the next part I have here is going to be an else statement. This else statement is that they haven't chosen to quit and they haven't won the game. And I think I asked you to give them a bit of guidance to tell them it would be higher or lower depending on what the guess was. So I'm going to do that inside this else statement. So inside this else statement, I'm going to have another if statement that says if guess is lower than number to guess. So if the number is 55, they've guessed 44. Well, then I'm going to tell them, I'm not going to have to break there, but I'm going to tell them higher. Spell it right. So that's the first one there.
No.
No, if their number is lower than the number they're trying to guess, they need to guess higher. The number is lower, but they need to guess higher. The opposite to that is going to be, they're going to print out lower. I don't need to worry about if they guess the right number because I already have dealt with that up here. So here's going to be lower. And that's it. That's all I need to do for those if statements to give guidance to the user. But the one thing that's very important is not to do that. The one thing that's very important is to increase my number of attempts, because that signifies that I've used up one turn. Okay. So that loop there, I think that's it. Well, they've less than 20 goes there, and I'm going to change this for the moment to be 5. I'm not going to make 20 goes. I'm showing you guys. Ask them to enter a number. They're going to take in the guess. If the guess is negative, we'll then quit. If the guess is correct, then tell them they're a winner. Otherwise, if the guess is incorrect, but they haven't used up all of their goes and they have not chosen to quit, I'm going to give them a prompt to tell them either higher or lower. And I'm going to say, well, that's one more attempt you've had. And then this finishes, my loop finishes. And I go back up again and I ask them to enter another number. So let's test this and see if this works. Okay, so. Okay, guess a number. I'm going to guess 13. Should be higher. Try and guess another number. I'm going to 56. Should be higher again. I'm going to guess 88. Should be lower. So it's somewhere between 56 and 88. I'm going to guess 77. Lower. I'm going to guess 66. Damn it. Right. I'm off the break. See ya. Right, let's try that again. Try and guess a number. 99. Lower. Well, obviously. 1. Higher. That makes sense. 55. Lower. 33. Lower. 22. Higher. Okay. Now, what's missing out of that? That's a slightly incomplete version of it. Because what's missing out of that is that if I used up all my goals, it should have said, hey, you've lost. You've used up all of your goals. And whatever it was. So actually, let's add in that bit there. So at the end of the go, that's the end of my loop here. I'm going to say if my attempts is equal to, in this example here, 5, because that's the one that I had a look at. I'm going to say lovely, helpful message, loser. Okay, so that in that case here, if they hit all of their goals and they still haven't got it right, they have lost the game because they haven't picked something. If so, else if guess is equal to remember to guess. Say goodbye there again. Okay. All right. Okay. So let me change that there. No, that's actually the only one I need. I suppose in here, I think I asked you to tell them how many guesses they've made. You could put that in there by printing out the number of attempts in either of the other two conditions. All right, so that'll tell me that's lost. But this, they're quite, like if I look at that there, we've got one Boolean expression there, one Boolean expression there, one Boolean expression there. And they're all just one Boolean expression. There's no ampersands in there. There's no linking up of larger expressions. I will point out that in the previous example, in the revision class 1, I was only looking for one character, or I was only looking for another character, or I was looking for any other character. I didn't combine them. But for this one here, I could say, keep looping around. So this is... So this version here is going to be simple Boolean expressions. Save that. And I'll save as Boolean class 3. And this will be complex Boolean expressions. So I'm going to drag some of those if statements up into the guard on the loop. So I'm going to say, while the attempts is less than 5, and while their guess is not, which is greater than 0, let's say. Okay, so while their guess is greater than 0, and while their guess is not equal to, so not equal to 0. Okay, so what this means here is this loop is going to run and keep running while they have made less than 5 goes, while they've entered in a positive number, so they haven't chosen to quit, and while they haven't won. That shouldn't be 0, that should be num to guess. So while they haven't won, they haven't quit, and they haven't lost. So while all 3 of them are true, we're allowed inside the loop. If we're allowed inside the loop, we're still going to ask the user, please enter a number. We're still going to take the number from the user. If it's less than 0, well, we won't ever get into the loop, so we can get rid of this. However, if inside here, this version here, they enter the right number, well then yes, they did win, so we can go into here. Otherwise, we can have the higher or lower, and we have attempts plus plus. So what I've done there is I've taken 3 statements and I've dragged them up into a single statement. And I've used the AND gates to make sure that it's all of them, that all of them have to be true. So you guys have done logic gates in computer hardware, definitely. Have you done them in Foundations? Okay. And you've done them a little bit with me. But basically, it's thinking about what's the validity of them. An AND gate means that every condition involved, if you have, so here I've got 2 AND gates, and I've got 3 conditions in total. All 3 need to be true for the statement to be true. If any one of them is false, the entire statement is false. So if we have 2 conditions, that means that we could have false, false, true, false, false, true, true, true. So of those 4 possible outcomes, only one of them actually allows you inside. It then becomes we have 3 of them. Of the 8 possible outcomes, only 1 allows you inside. If we have an OR gate or two OR gates in this example here, if I replace this with OR and this with OR here, it works in the opposite way. As soon as we get any of these three which are true, the entire statement is true, and it lets you in automatically. So in this example here, we've got 3 conditions to evaluate. We have a possible 8 combinations of values between all the way from true, true, true to false, 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 and everything in between. But there is only one condition which won't allow you in if there were OR gates. So what I usually do, if I have to build a Boolean statement that revolves around AND gates or OR gates, or both, is to work out, speaking to myself like a crazy person, how I am allowed into this loop, or if statement, or whatever it may be, and how am I not allowed in. And once I can articulate that, obviously in an exam environment, you can't talk out loud, but write it down as an English sentence. I'm allowed in here if I haven't used up all of my goals, and I've entered in a valid number, and I haven't already won the game. So you're kind of going, all right, I can see what I need to do there. And when you look at the words in between the word and or the word or, depending on which it is, they're much smaller things to deal with. They're much smaller things to break up and look at. For the majority of these complex Boolean statements where you've got bigger ones at that, do not look at it all at one thing. Take one section and go, all right, that one. Then take a smaller one. And so build it as 3 separate ones. And if your solution is the previous version where I've got the simple Boolean expressions, but it works, absolutely valid. For the assignment you're doing now, I think and I haven't actually written out a full solution for this, but I think you only have one scenario where you would have 2 logic or 2 Boolean guards with it, like an AND gate or an OR gate in between them. Everything else is like what I've done in the previous example, the first example I did, where it's a single thing I'm evaluating. For the worksheet questions, yeah, they were smaller problems, but I made the logic a little more complex to see, could you do that? Now, as first year students, you don't have to do that. You can have more code, more if statements, but it means that each guard, each if statement for each guard, each loop is smaller. So it's easier for you to kind of get your head around. And you just learn over time and over practice. Oh, do you know what? Those 4, I can actually bring that up to 1 or to 2. And you just learn how to work your way around them. Fair enough? That answer your question.
Yeah.
Right. I'm realizing I'm going off the tangent, so I have to make sure that I'm actually keeping track. Any other particular questions? Yes?
And you was asking if we could do even the difficulty of the game. It shows that
If you can do a which?
you can do the difficulty of the game.
Oh yeah, okay. So the difficulty of the game for this game here. Okay. So let's say we've got, all right, that's pretty easy to do. So the difficulty of the game is going to change how many goes you get, or, well, there's 2 ways you can change it. You can either change how many goes you get, or the range of numbers. That's the most logical thing that you would look at for difficulty. If you play video games and you change the difficulty, one of 2 things either happens. Either you end up with more lives, or you end up with more difficult enemies. So there's 2 routes you can take. Both of them are basically going to achieve the same way with this. So I'm going to have another variable here called attempt limit. And I'll set this equal to 0 to begin with. Okay, so this is what I'm going to do. I'm going to say, the way I'm doing this now is rather than making the game harder by having a wider number of numbers to guess, I'm just going to give them more or less lives, attempts, depending on which option I pick. So I'm going to have my attempt limit up here, which will mean that rather than having less than 5, I'm going to replace that with attempt limit. I also need to replace that down here. Okay. Before I go into this loop here, I need to ask the user what level do they want to play. So I would have something along the lines of One. And because John Romero now lives in Ireland, okay, so we've given them the little menu system. Hey, select your level, and you give them all their options. And I put numerical references beside them because I don't want to add in extra any I do not want to add in any extra variables unless I have to. So I'm going to reuse their guess. I can use it outside of the loop, because as soon as I go into the loop, the very first thing I am asked to do is enter in a number. So it'll automatically wipe what I have there. What I'm going to have here is I'm going to have guess is equal to KB dot next int. No? Next int. And let them enter in 1, 2, 3, or 4. I'm then going to have an if statement. It says if guess equals 1. You're going to see where I'm going to go with this. Else if guess equals 2. And actually, because we only have one line of code, I'm actually going to get rid of the brackets here and make it a little bit faster or neater to look at. So what I'm going to do, there's a couple of ways we can do this. What I'm going to do is I'm going to say, I'm going to set my values here, and I'm going to be mean about it just to say, in the interest of saving time and space. So if they select option 2, it's 10 lives. If they select option 3, it is 5 lives. And if they don't select anything, so if they just, if they select a wrong number, so if they select like 700 rather than the menu option there, well, then they get to play Ultra, which they have one. Okay? So what has happened now is when I run this game, the first thing it's going to say is, please select your level. And I'm going to choose. And depending on what level I pick, it will give me a varying amount of lives. Now, if I wanted to change it the other way, everybody always gets 20 goes. However, your life or your level is going to dictate your range. What I would do is I wouldn't generate the random number up here, but this number 100 becomes a variable. And so maybe normal is 100, hard is 1,000, easy is 50, ultra is 10 million, something like that. And so they still get 20 attempts, but there are 10 million possible outcomes you could go for. And it depends on what way you want to do it. If you were to play, last year I gave out Hangman as one of my assignments. And so you had difficulty levels there, and the difficulty level basically would be, for that one, was which text file of words do you read from, because I categorized the words into easy, so they were less than 6 letters, medium between 7 and 10, or hard 11 or above. And so that's how I categorized the leveling system for last year's. Fair enough? Does that make sense? Now I could, I don't want to spend too much time on it, but I could put this whole thing into a loop, and it keeps going around until they enter in a number 1, 2, 3, or 4. Any other number they enter in, it'll ask them again and again and again and again. So if they keep entering in stupid inputs, it'll keep going until they enter in a number between 1 and 4. At that point, it'll quit. Okay, and that'll be using your guess is greater than 1 and it's important that it's an AND gate there, because it has to be both greater than or equal to 1 and less than or equal to 4. If you have an OR gate there, every number fits into it, because every single number 3 downward, all the way down to negative 2.4 billion, is less than 4, and every number from 2 up to 2.4 billion is greater than 1. Okay? Any other questions? Yes.
Curious at the start when we set the class name.
Yep.
We're What's the difference between public class, private class, default class?
Okay, so for first year students, I would say just go with class. We will look at the idea of public classes next year in object-oriented development when you have multiple Java files. Basically, the public, private, protected is a access modifier. It defines what elements are allowed. Have a look at this. For you, a public class allows you, and the reason why I want students to use class rather than public class. If you use public class, your file name and this here don't have to be the same. If you use class, it kind of restricts you to doing that, and it forces you to have good naming parameters on your files as you go through it. As you get more experience and you get a year's programming under your belt, you can then start looking at, having files where you've got multiple. We've actually got multiple programs in one Java file, so it's not possible to have the correct name for every program inside there. So we're just going to. That's the reason why I do that. So if you see public and you're already making sure that your file name is matching your class name, it's not going to be an issue. It becomes an issue when they differ. Any other questions? It's 5 to 8. Do you want to go for a coffee, or do you want to keep going? We can keep going and finish up a little bit early if you want. You can go for a coffee and we can run to the end. Fine. You can go for a coffee and come back and work on your assignment for the last hour if everyone's up. Keep going, finish early. Okay, super. If you want to go for coffee, go and come back. You'll miss a little bit, but you won't miss a huge amount. Okay, so what else would you like me to cover?
YouTube.
The which?
The YouTube exercise, like we did last week.
You'll have to. I've got to draw a blank. Sorry.
Yeah, it's the best. I have to check again.
What did I do?
It's the method one.
Oh, the method exercises. Okay, all right. Yes, sorry, I have it here. So I had two classes I looked at last week. The first one is where I just had little methods where I had different types of returns and different types of inputs. And then the second one was a slightly bigger one where we looked at the idea of a Caesar cipher. So inside our method example here, we looked at the idea that we can now have code where we've got more than one block of functionality or more than one block of work space inside our program. So we've always have to have our public static void main because that's the runnable part of your program. If you don't have that, you can have Java files, and we will get to the point where you'll have code files that don't have a public static void main, but that's second year stuff. We don't look at that in first year. But when we have a program we want to run, we have to have our main method. But we can also have other sections of code in here that can have different elements of functionality. And what we did is we said, let's take a piece of work. Usually a piece of work is going to be duplicated. You run more than once in the program. And rather than having it copied and pasted multiple times in your program, you put it in one place and then you just refer to it. So if it's like these are all very small examples. You can see it goes from 11 to 14, it goes from 15 to 22, 23 to 30, 31 to 36. So they're not big examples. But if I had a method of code there that was 100 lines of code and I used it 20 times in my program, I could have 100 by 20, which is maybe 2,000 extra lines, well, let's go 1,800 extra lines of code inside my, 1,900 lines extra code inside my program. Or I could have 100 lines plus 20 lines where I call it, so I have 120. So it massively can reduce how much overlap is in there. And that's just from the footprint of how big the file is. It also allows us to improve our efficiency from the point of view of if I've got that piece of functionality, it's 100 lines of code, but I've got it copied and pasted 20 times in my program, and I need to change something in it. Well, then that's 20 opportunities where I might miss the update or forget the update. Oh, I overlooked that one. Whereas if we were using, if we were using methods, we would change it once, and then it would ripple through our program, because every time we refer to it, it would go back to the one that we know that we've changed. So I went through a couple of options here. I had no inputs and no returns, so you don't send any data into this method. You don't get anything back. It's usually for displaying methods. I have where I send in one input and I don't send it back. I send in two inputs of different data types and I don't send it back. I send in two inputs and I get a number back. So we can go through them one by one. So for no inputs and no returns, it's very simple. I call that method, this prints hello on the screen. Incredibly boring, but it illustrates what we're doing there. For the one input and no return, I send in a number, and that number will print echo that many times on the screen. So if I sent in 7,000, it would print echo 7,000 times on the screen. If I sent in 12, it would print it 12 times on the screen. Again, not particularly useful code, but it gives you an idea of, oh, if I send that in, that's going to make the code work the same way, but with different outcomes, because the value of X will change. So my loop will run more times or less times, depending on whatever that value is. If I had two inputs, so I take in an integer and I take in a string, and these are separated by commas, and we can have lots of these type of inputs. What I can do here is I can print that string X number of times on the screen. Again, I'm still not sending anything back. So you can see that we've got void, void, void here. It means that nothing's returned, nothing's sent back from this program. And then the last one, the trickier one, was the idea of sending in some values, and I have an integer here and a double here, and we return back something. So this was very simple. We take two numbers in and we add them together and return back the answer. I have a double as my return type because I'm taking in an integer and a double. An integer can be put into a double, but a double can't be put into an integer because it's a bigger range of numbers. So it makes sense that I use the lowest common denominator of data type to say, well, look, a double can hold all of my values. So I'm going to send that in. You can see here that my code is very, very simple. I'm just calculating whatever that result is. And I'm using this keyword return. And what the return does is it sends it back. It sends the answer back, the value back to wherever I called it from. And I called all of these methods from inside my main method. So here I called print, and I don't need to send anything in. I don't need to take anything back. When I'm calling print lots, I send in the number 3. 3 gets put into variable X inside this method. There. And then it treats this value here as 3 as we work our way through. When I send in 2 and Owen, well, then the same idea. It sends in for variable X, which is going to be my counter. It says, well, that's going to be the value of 2. And for string S, that's going to have the value of Owen. And then the last one is 4 and 12.34. That's sent in as the integer, the double. But you can see here, because I'm sending something back, I also have somewhere to accept that data. If you've got a method that has a return type, that has a value sent back to it, you should have somewhere to catch that return, that value, that answer when it comes back. If you don't, that's fine. The program won't break. It just seems a little bit pointless. Why would you create a method that sends some information back and you don't do anything with that information? That doesn't make sense to me, but it is clearly there must be a use case for it because it's possible. I could get rid of that and that code would work just as well. Well, it wouldn't print out the value A for me, but it would work just as well. There wouldn't be any issue with it. But ideally, we should have something like this. So that was the first example I did of methods. And again, I just went through lots of little combinations rather than doing anything big with any of the methods. The second one that we looked at was the idea of a Caesar cipher. So a Caesar cipher is where you take a string in and you shift the letters in that string forward by a number of digits in the alphabet. So in this example here, my example here was the zookeeper's ham sandwich, and I know I've misspelled sandwich, and we have 11. So it's going to take each character in that string and shift it forward 11 places. And so we have our method here, this is our method here in code, and we send in S, which is going to be our string, and shift, which is the number of spaces we're moving it forward. And so this is, if we look at the signature of that method, it's reasonably simple. We're sending in one string and one integer, and we're returning back a string. But you can see that this method here starts on line 12 and goes all the way down to line 36. So it's a big enough method. It's a reasonable amount of work. But the stuff that's relevant to our program or to the methods is really just this line up here and this last line here where you return the output. Everything else in between, I could have removed the word method and we could have just written a program that does the exact same thing inside public static void main. So from a method point of view, we haven't added, as I was saying last week, methods don't add any new features to our code. It just allows us to section off our code into little parts. The advantages of that become more evident the more experienced you become, but it's basically reusability and modularity or portability. You can unplug one section of your code, make it that bit work better and plug it right back in, and none of the other bits of code don't get affected by that. They don't need to be aware that something has been amended. It's how operating systems work. When you run your Windows update or your Mac OS update, and it says, hey, we've got updates for you, and they give you a list of all of them. What's essentially happening is it's unplugging one little section, inserting the new version of it in, and making sure that all of the inputs going into it and all the outputs coming out of it are still working, even though the inside might work completely differently. It doesn't really matter. If you think about cars, we've gone from having petrol cars with leaded petrol to petrol cars with unleaded petrol. Now, the difference to the input and output there is slight. The fuel goes in, the engine power comes out. All we're changing is the type of fuel that goes in. The internals of what's happening inside that car are going to be reasonably the same. So we have a different type of input. The functionality of the combustion engine is still working. If you compare then an unleaded petrol car to an electric car, you have a very different scenario. You still have fuel in and engine power out, but the internals now are completely different. If we were to have Flintstone car, which is basically feet in the bottom running, we have fuel in, which happens to be people, and then engine power out. But the internals of that, of how that car works compared to our electric car, compared to our petrol car, compared to our leaded petrol car, are all very different. So the idea of having a module or a method here is that I could say, let me take all that code there for the encode method, let me take it out. Now that I'm not just at week 12 of semester 1, I'm at week 12 of year 4, semester 2, I'm at the end of my degree, I'll be able to write a much better version of this. It'll still work the same way, the user will still think it's working the exact same way, but things are working much more efficiently in the background. And I don't know why the projector turned off and nothing else. It was well timed though, wasn't it? Right. Okay, does that make sense? I can do, let's see if I go into Firefox now, let's see if I can get an exam paper and see if we've got an example of a method question here.
Will it be flagged if you try and name your method? The name of the method? Like,
not necessarily, because we won't cover it this term, but there is it's really, really useful, but probably for first years, really, really annoying term called overloading, which is where you can have a method, you can have multiple versions of the same method, but as long as their inputs are different, they're all acceptable. So it's like if you have a method called application form, and your application form has, let's say, 5 things to fill in it. So you have a method where you send in first name, last name, email address, phone number, and postal address. You send in all 5. You also could have an application form where you have first name, last name, email address. You just send in 3. You have an application form where you send in first name, last name, phone number. So you send in 3 there, or phone number and email. So you can have all of these different combinations and permutations to work through that. So if you're getting an error if you're not getting an error where you have 2 methods and you've accidentally named them the same, and it's only using one rather than the other, you shouldn't have them the same. The same with variables, you shouldn't have variables named the same in your program. You ideally shouldn't have variables or methods named the same in your program either. Exams information. So just so you can see here, when you log into Moodle, if you get into exams information, you can see all the papers that are available. I've never clicked on the faculty. I don't know why you'd want to, but maybe you can get access to those papers if you want. But we go from 2014 forward. So you have about 3 to 4 years, 3 full academic years of papers there. If I look at computer programming from 2014, and I cannot remember what I wrote, so this will be interesting. This is a bit of a scatter shot because I don't know whether I wrote a question in this exam paper that specifically looked at methods, but let's have a look. Okay, there's examples of your Boolean expressions there. Okay, so here's an example of a method. Now, a little bit tough to do at the moment, but a prime number is a number that's evenly divisible by only 1 and itself. Create a method, or function in this example here, that accepts in a number n from the user and prints out all of the prime numbers from 1 up to that number. So that would have an input of 1 integer, and it would have no output because I'm just printing this onto the screen. So it says prints, and that means that we're doing that rather than having anything returned back. Okay, so that's assertion. We're not doing that. That's file access. Actually, let's do this one here. So a string consisting of a sequence of characters, both vowels and consonants, and spaces. For example, Griffith College, Dublin. Design a program to input a string str and output the value of that string with all of the vowels omitted. So, for example, if we enter in Griffith College, Dublin, we get this as our output here. Okay, I would like you, the next, let's take 15, 20 minutes to have a look at this, to do that, but do it as a method. So you're going to write a method that is going to take in a string and return back a string. But what happens in the middle of that method is it's going to trim out all of the vowels. Okay, my advice on this, to make life easier for yourself, it's a string question, so we're going to deal with string questions the way we normally deal with string questions, going from the first to the last character. And the second bit of advice is you are not restricted to only having 1 string in this question. You can have another string or multiple strings if you wish. Do you want to attempt it, or do you want me to just go through the solution? Okay, all right, okay. For today, because you've got a assignment test standing, we'll go through the solution. However, and I will point this out, that we have a class test coming. It is pen and paper based. We will have a class of revision material for it. I'm waiting for a schedule to see when that is, but that is very much like a question I'd ask you to do in the class test. Okay, with paper, yeah, with paper. So you have 2, but this is preparatory for your examination in May, which is a 3-hour pen and paper examination. So it's giving you exposure to that environment so that you're not completely out of water. But let's have a look at this, and let's say rather than a program, we're going to design. We're going to design a method to do this. Let's go here. File, save as. Pass 4. 4. Yes. And I know. Okay, so Griffith has 4 here. I'm not going to bother with user input on this, just to make it a little bit neater for the output. I don't need a random number. Let's actually get rid of most of the stuff here. But I will put it into a method so you can see methods work. Okay. So we're going to have here public static string. This is going to return back the string data type. The method is going to be called no vowels, and it's going to take in a string str. And I'm going to do something there in a minute. The way I'm going to call this is I'm going to say string s is equal to no vowels, and we'll go with the same string again. So Griffith College, Dublin. I will leave in the uppercase and the lowercase in here just to make it a little more interesting. we're going to have our string there. That's fine. I'm going to create a couple things here. So I'm going to create int counter. 0. I'm going to create another string here called t for temporary, and that's going to be equal to an empty string. And you'll see why in a moment. And I think that's all I need. So my loop is going to say while counter is less than str.length. I'm going to get the current character. Char c is equal to str.char hash counter. No. Counter. Get the current character. I need to check, is this character a vowel? So let's check for all of the vowels. So we're going to have here if c is equal to a, or c is equal to a, or hang on. I'm doing this the wrong way around, so it's not equal to. And it should be, if it's not equal to, it has to be not equal to all of them, which means it has to be an ampersand, not. There we go. E, I, O, U. Okay, so there's my if statement. And it's going to make sure that the character I'm looking at is not equal to any of those. So the mistake I usually make when I'm doing this example is I leave this with ors. Because if you're checking for the positive, if it's equal to any of them, then you use or statements. Because any of them means as soon as it finds one that matches, great, we go into it. What I want to make sure is that it's not equal to any of them. And so that is going to mean that I'm going to need to have AND gates in between it. Because if I had OR gates here, if I entered in capital A, well, capital A is not equal to lowercase a, it would automatically add it in. So we have a problem there. But if it's not a vowel, so if it's only a consonant, what I'm going to do is I'm going to say T is equal to T plus C. So T is our temporary string, remember? And so what I'm going to do is the way I would approach this is I'm going to build a new string, only the consonants. So whenever I find a character that is definitely not a vowel, I'm going to add that character to the end of my current temporary string. So it starts out empty, and then it'll take capital G, and then it'll take a lowercase or, and then it'll skip, and then it'll take an F, and it'll skip, and it'll take a T and a H and a space, and a C, and it'll skip. So it's adding letters, but only when they're not equal to vowels. Counter plus plus here. And at the very end, after that loop is finished, we're going to go return T. Okay, so this is my method. I'm going to send in my string str. I'm going to have my counter variable so I can go through my loop. I'm going to have my variable T to be my output string, my temporary string for the moment. I'm going to check every character in that string, get the current character, make sure that character is not equal to a vowel. If it's not equal to a vowel, add it to my output string, move on to the next character. And that will keep going until I've checked every character in that input string. And at the very end, I will have a new string with no vowels in it. So it's basically the subset of my original string, only consonants and spaces. And that will be sent back. And then up here, I send that in there. The last thing I need here is a print statement. So system.out.print ln s. And that will print out whatever the output of that program is. While I'm looking at this, the reason why I enumerated through all of the vowels is because I'm looking at my possible values. If I am assuming I'm only going to have alphabetic characters, that's 26, but I have uppercase and lowercase, that's 52, and I have space characters, that's 53. It is much easier for me to give 10 really specific cases rather than 43 specific cases. So I'm going to be lazy in this scenario, and I'm going to write less. So basically, if it's not any of these, so it's the other 43 possible characters, and that's not including punctuation, symbols, numbers. If it's not any of those, well then I'm only going to be, or I'll add it onto the output string. If it is one of these very small subset of the characters that I can type, well then I'm going to allow it into this. Okay, just double check this works. This is class 4. Revision class 4. And it prints out Griffith College Dublin with no strings. If I were to put in, I mean, my name would be ridiculous in this, but let's put it in. Run it again. They get a much smaller value there.
Can I just ask for the while loop?
Yes.
Why did you put str in there? Because previously you've been putting in like, I know because it's up there, but why is it TRS? Because you've declared like string T is that, and then above like.
Oh, okay. No, literally that's just a name. The exam paper says it takes in a string str. That's why I use it there. Sometimes I say so accepts in number n. I don't define it there. I don't define it there. So sometimes I will give you the variable name inside it. That's not a big deal if you don't use it. If I use string s rather than string str, that's absolutely fine.
But is it
The s and t, and I'm saying it's going to be s or t, that has nothing to do with it.
Could they be? They could not probably the same. But str.
No. So what happens here is this string here gets put into and is represented as actually. Well, let's throw this into Jelly so I can show you what's happening as we go through it. Let's pick a much smaller string. Let's pick just that. So each of those strings are independent in themselves. We could overlap them and reuse them if we really wanted to, but only in certain circumstances. So you couldn't string str and string t inside the method would have to be different, because otherwise you're overwriting the string while still trying to work your way through every character. So as soon as you overwrite it once, it's changed what that loop is going to do. So it affects it in that respect. We could have, up at the top here, we could have sent in variable s here. So I could have done that. That would work. Send in s to, well, actually, I need to define what s was somewhere. So I need to have something. I'd need to have something like that. But that would work because I'm taking in on the right hand side the original value of the string s, sending it to this method here. It runs it, it updates it, and it sends back the updated version, which would be the same string with no vowels in it. Does that make sense? Okay, Jelliot. Okay. So what's going to happen now? We take my string, it adds it in. It's going to go my counter. String t is empty to begin with. Is 0 less than whatever that is, 12? Yes, it is. Okay, so we go in. Is character that as capital E? Is capital E equal to A? No. But also, is it not equal to capital A? No. And so what's going to happen now is it's going to keep going until it gets to capital E. So we'll see, is capital E not equal to that? No, it's not equal. They're two different letters. But when we get to the next one, is capital E not equal to? Now, see, that's wrong because they are equal. So this will come back as false. And as soon as it's false, it breaks. It doesn't bother evaluating anything else. Well, you're not allowed in. Any one of these checks are incorrect or are false, well, then the whole thing is gone because I have AND gates in between them. So it'll tell me now true and false gives you false, which means that I'm not going to bother. False and anything gives you false. So I'm not going to evaluate any of this, and I'm just going to move on to the next character. It's false and false and false. So it'll basically keep running true. All of the other options are there, but because false is with it, we're not even going to get the characters because false and anything will always be false. To move on to the next character is 1 greater than that, and so the same thing is going to happen to get lowercase o, and it'll do the same check. So O is not equal to A, O is not equal to uppercase A. O is not equal to E, O is not equal to uppercase E. So it keeps working its way through, but then when we get to capital O, you'll see here that, or sorry, to lowercase o, that we will have that's false, and then it continues the other ones, but doesn't bother evaluating them because it doesn't matter. I've found that one wrong thing in there and everything joined up. And so far, variable t is empty. I haven't added any variables to it yet. Now this seems like a lot of evaluation, but remember that this is really slowed down for animation. And even if you have the animation at maximum speed, it's still really slowed down so it's visible for us to see. This is happening almost instantaneous from our point of view. So we're on to the next character now, the 4th character, which is going to be N. And then we'll go through all 10 combinations because it won't be equal to any of them. And because of that, we'll get to add that character N onto the end of our string, which happens to be empty, so it becomes the first character. So you can see now that string t here, moves out of the way, has 1 variable inside. And now we have space, and space will be added on, that's fine. And then we're going to capital C, and capital C will be added on. So if I just speed this up a little bit so you can see it running to the end. So it goes through all 10 evaluations. And probably for the trying to get the jelly, I should have only looked at lowercase values, but C is not any of the vowels. I'm not sure all the rest of them. And it's working its way through there. And we've added C into it there. So you can see this is slowly built. This variable up here is slowly building its way up as it works through these. And as it comes across the vowel, it goes through all the evaluation. It gets to a reasonable look. Look, I'm going to skip it here. So it doesn't really matter what it is. Then we get onto our ors and we're able to add them on. So it's added on kind of one at a time as it's building its way up. And then our last, those are our ors, I'm sorry. And a couple more to go. Okay, well that's finishing out. Does that make sense to everybody? Yeah? Okay. Any other topics or any other questions?
So, could that be done directly to the string without creating a substring and telling it not to print out the vowels?
Yeah, I mean, so it depends on what your output. So this, the way I wrote this is that it would send back a string. But if you just wanted to print it on the screen, rather than building a new string, you just decide to print C. And you just have systemnet.print, not systemnet.print ln, otherwise it go all down. one character per line. But yeah, if I just wanted this, excuse me, to work without sending back a string, just print it out. Absolutely, just print character C, and it'll only print out the ones that aren't vowels. Absolutely. Any other questions? So far this semester we've looked at printing out to the screen, we've looked at expressions, we've looked at variables, we've looked at if statements, we've looked at user input, we've looked at loops, we've looked at strings, and we've looked at methods. So there's a lot of content there, and as I keep kind of reiterating, ignoring strings and methods, we have those 5 core fundamental elements that will allow us to shuffle them around to basically do everything we're going to do between now and probably the end of second year, if not into third year. We don't add a huge amount more. Anything else we are going to add on to this will be strings. We add on a new data type or a new way of holding information. Methods, we haven't added any new functionality into our code, just looked at a way of sectioning it off. The next topics we're going to look at is going to be arrays and 2-dimensional arrays, but again, that's dealing with collections of information. We're then going to look at file access, just a different source of information. Rather than reading from the keyboard or hard-coding information, we're going to read from a file. We're then going to look at sorting items, how to take a collection and put it into a sorted order. We'll then look at very small but at objects and how they work and how you can kind of encapsulate data. But we're still using system output, expressions, variables, user input, if statements, and loops. We're just, everything else we're adding onto it is just, oh, here's what we could do when we were typing or hard coding in all our input. We now can read from a text file on our machine or on a network somewhere. What we can do where we were just writing our code as one big block, we can now break it up into small parts. And it just shows you how to kind of gather information and reshuffle information. Even with the second year course I'm teaching now with daytime students, we're looking at different ways of approaching a problem, but we're still using variables, input, output, expressions, loops, and if statements in every single question. They are the DNA of programming. Without those 5 elements, you cannot write a program. So you need a way of being able to write those. That's what we kind of hammered into for first year. Okay. Yes.
That book that you put on Moodle, Range Problems in Computer Science,
Yes.
the link is not accessible.
Oh, whoop. Okay, I will fix that once I finish this.
If you have another.
Yeah. No, I have it. Do you know what it was? I copied it over from last year's archive and probably pointed to the course you don't have access to. I'll get that fixed. That's no worries. Now, with that book, Graded Problems in Computer Science, they are just abstract problems. You won't get a solution for them. They're not specifically for Java. Is the reason why I like the book is it was written in 1987, I think, maybe 1983. I can't remember, but because it deals with those fundamental elements, they're applicable for any programming language. We're doing Java now, but if over the summer you said, you know what, I want to learn Python, or I want to learn C#, or I want to learn Ruby, you could take the same problems and implement them in each of those languages. And the solutions wouldn't be identical, but the approach to the problem would be pretty much the exact same in every one. So it's a really good tool. I will update that. Yes. Any other questions? Everyone's happy enough? Bursting to get out of the room. So, what we'll do is there's about an hour left. I'm happy to hang on for an hour if you want to work and then ask questions as you encounter work. For those of you who are creaking your chairs trying to get out, your assignment is due for Monday. Okay, so the full-timers handed out today. Because I've often got requests from part-timers, can we just have the extra weekend to work on it because it makes a difference. So you can have the weekend and submit it on Monday. That's fine. Remember, I'm not here next week, so you don't have a class with me next week. At this point in time, I think it's going to remain that way. If for some reason I've got another unavoidable commitment, if I'm able to switch with 2 other lecturers, because all of the other days you have 2 classes, well, then I will do that and I'll inform you as soon as possible. But I have a feeling that it's going to be next week we don't have a class. We'll return back in the new year and we'll continue from where we are.
Sorry, you said we were going to have like a revision class before
Yes.
the class. Do you know how we be made aware of that?
So I'm waiting to hear back the feedback on it. I'm also waiting to hear back the confirmation that we're doing. Usually what would happen is we do this in the month of January. You have one examination in January, I think it's on the 9th of January. As your year head, my recommendation was if anybody is running revision classes, we do it in the week of it was the week of the 16th. So what that would mean is that you would have done your exam, you come in for, if anybody, and generally what happens is not everybody will want to do revision classes. And then you'll have a week gap, and then you'll be starting second semester here. So it gives, again, it breaks it up a little bit. If for whatever reason, the decision comes from the faculty that, you know what, we don't need to have those January classes because you actually have exams, so you're not going to forget everything that you've done over the first semester. And that's the only reason we did them in the past, is when we had no exams in January, people would finish up in December and come back in February, and the first 3 weeks would be a frantic recap of everything we did in the first semester. If it ends up that way, what I'll do is I'll push the class test to the second week, and we can use the first week for a revision class of some effect. Although this was kind of a revision class, but yes. A revision class where you will practice handwriting questions. Fair enough?
I want to know, the day we come back for school
Yeah.
will be the January 9th. For the exam, or before that we have to.
So your exam is on this day, so obviously you're required to be in on that day, and you know the time is during the day. Yep. Okay. Just making sure of that. And that is for Gemma, isn't it?
Yeah.
Yeah. Okay. So Gemma may, and it's up to Gemma whether she goes or not, may request a booking. Not on the first, obviously, but some more time before that for a revision class. I don't know. So that will be the only required attendance before that date. And even at that case, if it's a revision class, it wouldn't be required attendance, but it would be on. If extra classes go, and I'm waiting to hear back are people doing this or not, it'll be in this week, I would imagine. And second semester starts in this week here. I think. I actually can't remember when second semester starts. It might actually start the 4th of February. Is it? Oh, then you would have. All right. Okay. Super. Okay. Well, it gives you a little bit of a break. If for whatever reason we can't organise a revision slot in January, and as a group you're very eager to do it, I can organise something digitally, where it's either Skype or Zoom or Google Hangouts or something where you could, even if it's me sitting in front of a computer typing out screencasting and you're sending me comments, I got no weird comments this week, you're sending me comments, I can absolutely do that, but we'll see how it goes. Obviously a physical classroom is better because it gives you the chance to ask questions without internet. But if we can't do that and the class is clamoring for it, well then we can go ahead and say, look, we'll do a Skype meeting or something where we can kind of go out. Fair enough? Okay, so with that, if I don't see you, have a good December, January period, whatever that means for you. Well, it means New Year for everybody, but not everybody celebrates Christmas. So happy Hanukkah or happy Christmas, whatever it is for you. Or happy 25th of December if it means nothing to you. Happy day, all the shops are closed. Except for McDonald's. My full-time students used to love working at McDonald's, especially the Chinese students. They'd get, I think it was quintuple pay on Christmas Day. So they'd go in and they'd work 6 hours and get paid for equivalent of a week's work. And it didn't make any difference at all. Okay, folks, if you're hanging on, I'm going to stop the YouTube video now. If you're hanging on, if you want to use the room for work, or if you want to ask me other questions, I'll be here for